All right, students, welcome to lesson 22, finding the constant rate from a table, a graph, an equation, and a word problem. We're going to compare those constant rates and explain what they mean. So just as a reminder, constant rate is like average speed over a time interval. So for example, if Erica sets her stopwatch to 0, and then she switches it on at the beginning of her walk, and she walks at a constant speed of 3 miles per hour, the constant is 3 miles per 1 hour. So our x is the hours, the time, and the y is the speed of 3 miles per hour. So obviously, if she doesn't spend any time walking, she's not going anywhere. But if she spends 1 hour walking, she goes 3 miles. And if she spends 2 hours walking, she goes 6 miles. And I think you can guess in 3 hours, that would be 9 miles. Okay, so that's our table. If we divide y divided by x, we get our constant or our unit rate, which is 3 divided by 1 is 3 over 1, 6 divided by 2 is 3, 9 divided by 3 is 3. So our constant keeps being 3 over 1, which we can put in the equation because 3 over 1 is 3. So the constant is y equals 3x. For speed, if you want to know how far she walked, you would take the time x and multiply by 3. And that goes in our graph too here. So time is on our x-axis. So time goes across to the right. And distance is the y-axis. So distance is y. So after 1 hour, she goes 3 miles. So 1, 3. After 2 hours, she'll go 6 miles. So 2, 6. So all of these things are related. The graph, the table, and the equation, and they all are connected by our unit rate, which is our constant, because this is a direct proportional relationship, because she starts at 0, 0, and she goes up at a straight line or a constant for each point on the table. So let's create a table, a graph, and equation for this problem. If a faucet leaks at a constant rate of 7 gallons per hour, suppose y gallons leak in x hours from 6 a.m. Express the situation as a linear equation in 2 variables. That means we have to have a y and an x. Our 2 variables are y equals our constant or our slope times x. So what's our constant? 7 gallons per hour. So if we did time and the amount, or the gallons, we would have x and y. So in 1 hour, time of 1, 7 gallons. Right? So our constant y over x is 7 over 1, or just 7. So our equation over here is y equals 7x. So we've got a table. 1 over 7, 2 hours would be 14, 3 hours would be 21, etc. We've got a table. We've got our constant here. And we have our equation. And what are we missing? We're missing our graph. So our graph would be, if we have the x-axis and the y-axis, at 0 minutes or 0 hours, there would be no leak. But after 1 hour, there would be 7 gallons of water. So we can draw a line between that and that with a constant rate of 7. So what does this mean? The graph means here that after 1 hour, 7 gallons of water would leak. After 2 hours, 14 gallons of water would leak. After 3 hours, 21 gallons of water would leak, because it's leaking at a constant rate of 7 gallons per hour. And we even have this wonderful equation, y equals 7x. So let's take a look at another one. This graph over here represents the constant rate at which a train travels. If train B travels at a rate of 95 miles every 1.5 hours, which train is traveling faster? How do you know? What is a different way you can answer this question? So let's take a look at this. This train is traveling after, so this is time, after 1 hour, this train travels 60 miles. After 2 hours, this train travels 120 miles. But this other train is 95 miles every 1.5 hours. So if I go 1.5, which is about here, and I go up to 95, which is about there. But I'm not sure if it's there or right on the line or there. This kind of looks like it's between, this kind of looks exactly at 90. But I'm not sure. I have to figure it out. I can take this first point here. This is my constant. This train, train A, travels at 60 miles per hour. That's my constant, 60 miles per hour. So I have a y equals 60x. This one is 95 every 1.5 hours, so that would be 95 over 1.5 hours. So I can do this and divide it in my calculator and get an answer. Or I can do this and say, well, what if I did 1.5 times 60? 60 times 1.5. What would that be? So 60 times 1 is 60. Half of 60 is 30. So 60 times 1.5 would be 60 plus 30, which would be 90. So this train is traveling at 1.5 hours, would go 90 miles. And this train at 1.5 hours would go 95 miles. So which train is going faster? Train A that goes 90 miles in 1.5 hours, or train B that goes 95 miles in 1.5 hours? Well, looking at that way, this one is definitely faster because it goes 95 miles in 1.5 hours. I hope that makes sense to you. So we're putting a lot of skills together. We're translating word problems into an equation. We're creating a table and a graph from the equation. We're comparing slopes, which are unit rates. We're knowing what individual points on the graph mean in terms of the word problem. Okay, so we're putting all of that together. That was a lot of 7th grade stuff as well as a lot of 8th grade stuff. So let's practice it. Do at least 2 problems from 1 through 5, and do problem 6. 6 is a little bit different, and it takes you a little thinking. Don't spend more than 15 minutes on your homework.